Imagine standing in the shadow of a monumental structure, a feat of ancient engineering that defies explanation. How did civilizations, without the benefit of modern tools and technology, create impossibly intricate buildings, colossal statues, and massive stone highways that still puzzle experts today? You might be wondering what secrets these engineers harbored, what methods allowed them to move 15-ton stones with such precision that even thousands of years later, we struggle to replicate their techniques. Stick around, because in this journey, we're going to unravel the mystery of ancient civilizations that built the impossible and uncover valuable insights into their remarkable ingenuity. As we dive into this captivating tale, let's first set the stage. Imagine the pyramids of Giza, their towering peaks piercing the sky, each stone block meticulously positioned to form an awe-inspiring structure that has outlasted millennia. Did you know that the Great Pyramid was originally covered in polished casing stones that reflected sunlight, making it shine like a beacon? This architectural marvel, built around 2580 to 2560 BC, was the epitome of ancient Egyptian engineering. But how did they accomplish such feats without cranes, pulleys, or even basic machinery? It's a question that transcends mere curiosity. It speaks to the very essence of human creativity and problem-solving. If you think the methods employed were primitive, prepare to be surprised. Let's break it down. The ancient Egyptians relied on a variety of ingenious techniques, such as using sleds to move massive stones over wet sand to reduce friction. They even employed a system of levers and manpower that would astound modern engineers. Surprising, isn't it? But the Egyptians were not alone. Across the globe, similar wonders arose within other civilizations, leading us on a quest to understand a shared foundation of human ingenuity. Now, let's skip to the sprawling complex of Machu Picchu, hidden among the clouds of the Andes in Peru. This Incan citadel, built in the 15th century, is a masterpiece of stonework without the use of mortar. You might be asking, how did they achieve such precise joints? The Incas used a technique called ashlar masonry, where stones were cut to fit together without any binding materials, creating structures that still stand strong today. But it gets better. The layout of Machu Picchu reflects advanced knowledge of astronomy and agriculture, marrying utility with art in ways that many still can't comprehend. As we traverse through history, from the towering ziggurats of Mesopotamia to the grand temples of Angkor Wat in Cambodia, a fascinating picture emerges. Each civilization had its unique solution to the daunting task of construction. The Mayans, for example, built their magnificent cities using locally sourced limestone, a material that was easily quarried and shaped. But their buildings, often aligned with astronomical events, reveal a sophisticated understanding of their environment. How did they know when to plant and harvest? What comes next will leave you speechless. There's a chilling resilience found in the very stones of these ancient structures. Ancient Rome engineered aqueducts that span miles, moving water with precision by gravity alone. How did they calculate the incline required for such extensive water supply? Using simple tools like the leveling instrument, the Romans mastered the terrain and created a network of aqueducts that included bridges and tunnels, some still functional nearly 2,000 years later. These structures tell us about not just engineering but the social structure of the Roman Empire, highlighting the importance of water to their civilization. But what about the enigmatic structures of the Nazca lines in Peru? They stretch across the arid landscape, vast geoglyphs that can only be fully seen from the air. Perhaps you're wondering why they were even created and who designed these intricate drawings. While theories abound, one thing is clear: the Nazca had an understanding of their environment and used simple tools to carve these massive shapes into the earth. Some speculate they used long ropes and stakes to create perfect lines, measuring entire landscapes in ways we often take for granted in our technologically advanced world. Now, hold on tight as we shift gears. What if I told you that some scholars believe the knowledge to build such incredible structures wasn't just local expertise, but perhaps a shared understanding across different ancient cultures? You might be shaking your head in disbelief. How could this be possible? given that these civilizations were separated by oceans and mountains. Yet, consider this, the pyramids of Egypt share mathematical revelations with the ziggurats of Mesopotamia and the temples of Angkor Wat. There's an underlying thread of knowledge that seems to connect them all, a hint of a lost understanding of engineering that transcends time and geography. For instance, the mathematical prowess required to construct the Great Pyramid speaks volumes about the Egyptians' understanding of geometry. The ideal slope of the pyramid, representing the rays of the sun, was calculated to be around 51 degrees, closely mirroring the angle of the Great Sphinx's face with the constellation of Leo during equinoxes. This isn't merely a structure, it's an expression of their spiritual beliefs intertwined with remarkable architectural precision. But let's switch continents again and talk about the awe-inspiring monolithic structures on Easter Island. How did the Rapa Nui people transport those massive Moai statues, some weighing over 80 tons? Their secrets have long fueled speculation and intrigue. While some theories suggest they walked the statues using a sophisticated system of ropes and balance, others propose that they rolled the stones on tree trunks or sleds. Yet, the truth remains elusive, shrouded in mystery that makes you wonder what other secrets lie hidden beneath the earth. Ever thought about the engineering behind Stonehenge? This prehistoric monument in England has baffled archaeologists for centuries. The stones, some weighing several tons, were transported from at least 200 kilometers away. How did ancient man achieve such an extraordinary feat during a time when they had neither trucks nor cranes? Recent theories suggest that they used wooden sledges and waterways to transport the stones, possibly involving a massive communal effort that reflects the organization and social cohesion of their society. Let's not forget the intricacies of the Great Wall of China. Constructed over centuries, its initial forms emerged as early as the 7th century BC. The construction methods varied depending on the region. Some walls were built from tamped earth, while others used bricks or stone. Can you believe that different dynasties used whatever materials were locally available, often recycling older constructions? What's even more impressive is the sheer scale, adding up to about 13,000 miles. It's proof of humanity's relentless drive to adapt and build, regardless of the available technology. As we uncover these ancient marvels, we must also consider the cultural factors driving these projects. What motivated civilizations to pour vast resources into constructing monumental structures? Often, religion and belief play crucial roles. The Egyptians believed that their pyramids helped the pharaoh ascend to the afterlife, and thus every stone carried profound significance. Similarly, the Japanese Shinto shrines were places of worship and reverence to nature. The time frame to build such structures was often lengthy, requiring immense sacrifices and dedicating generations to meticulous, labor-intensive work. How does that kind of commitment manifest in our modern society? Each ancient civilization constructed not just buildings or monuments, but legacies steeped in meaning. The unparalleled achievements of these engineers remind us of the creativity embedded in humanity. Their structures stand as a testament to what is possible when community, belief, and raw ingenuity merge. Yet, as we ponder their greatness, it's vital for us to learn from them. We're on the brink of revealing even more insights, peering over the horizon of what else these civilizations achieved in their relentless pursuit of greatness. What other challenges did they face along the way? What unforeseen innovations emerged? And more intriguingly, what can we learn from them for the future of our own buildings and cities? Whether through the towering ziggurats of Mesopotamia, the serene temples of Angkor Wat, or the intricate networks of the Inca, each tells a unique story of human resilience, adaptability, and a quest for something greater. In these complex structures are lessons of teamwork, innovation, determination, and a connection to the earth and cosmos that we may desperately need to rekindle in our modern age. So, hang on tight, because in the second half, we're about to dive deeper into the ingenuity, insights, and the incredible cultural legacies that continue to shape our understanding of these ancient civilizations and their impossible structures. Keep your curiosity piqued, as the journey is far from over. As we dive deeper into the legacies of these remarkable ancient engineers, we must confront the challenges they faced in bringing their ambitious visions to life. The construction of monumental structures was not merely an act of physical labor, it was a dance with the environment, a cultural expression, and a testament to their beliefs. Every block laid, every stone carved, and every road paved was a reflection of their society and the values they held dear. This interplay between culture and architecture reveals critical insights into their existence, one that we can learn from today. Let's shift our focus to the extraordinary achievements of the ancient Greeks. Their monumental temples, such as the Parthenon in Athens, showcase a mastery of aesthetics, engineering, and mathematics. Built between 447 and 432 BC, these structures were designed not just to honor deities but to embody the very principles of harmony and proportion. The Greeks employed precise calculations and had a profound understanding of optical illusion, so they designed the Parthenon with slight curves in its columns and steps, an optical correction that makes it appear perfectly straight. Their ingenuity reflects an intricate blend of science, art, and socio-political ideals. What drove such sophisticated design choices? How did this influence their society's notion of beauty and power? The techniques used by the Greeks were also critical to their success. They developed various architectural orders, Doric, Ionic, and Corinthian, each with its own style and purpose. The Doric order, robust and simple, spoke to strength, while the Corinthian order, adorned with intricate leaves and scrolls, represented luxury and grandeur. The ability to choose the appropriate style for a specific building indicates not just a technical capability, but also a deep-rooted connection to their cultural identity. Such architectural diversity teaches us about the importance of reflecting our values in what we create. Now let's explore the role of urban planning in ancient civilizations, particularly in the Indus Valley. The cities of Mohenjo-daro and Harappa, flourishing around 2500 BC, were marvels of urban design. They featured a grid layout, sophisticated drainage systems, and an understanding of public health unparalleled at the time. Streets were carefully planned to ensure proper sanitation and efficient traffic flow. What propelled this level of organization? Could it be that the advanced societal structure of the Indus Valley civilization demanded meticulous planning to support trade, agriculture, and daily life? Their meticulousness extended to engineering, as they used baked bricks standardized in size, ensuring compatibility and durability in construction. This shared knowledge of brick-making and construction techniques not only highlights their technical skills but also emphasizes a collective responsibility and a tribute essential to the cooperation needed for such expansive projects. The framework from which they built their civilization serves as a reaffirmation of the importance of collaboration and achieving common goals. While the Indus Valley civilization thrived on urban planning, let's not overlook the rich diversity existing in ancient cultures across the Americas. The Olmecs, known as the mother culture of Mesoamerica, created colossal heads carved from basalt. These impressive monoliths, often weighing several tons, were transported from distant areas, requiring exceptional coordination and teamwork. The Olmecs' legacy paved the way for the Maya and Aztec civilizations, who took monumental architecture to new heights. Intriguingly, the Maya adopted and adapted various building techniques, such as the corbel arch, enabling them to create grand temples, palaces, and observatories. Their structures, aligned with celestial events, reveal their astronomical knowledge and a profound respect for the cosmos, a philosophical underpinning that still captivates us today. One might wonder, how did the Maya develop such advanced understanding without telescopes? Their observations and interpretations of the night sky are testaments to unyielding curiosity. In a way, they remind us of the thirst for knowledge that characterizes human nature, a quality that transcends time and culture. As we travel further into the past, let's shine a spotlight on the less conventional yet groundbreaking solutions to construction challenges presented by different civilizations. Consider the Buddhist stupas found throughout Asia, such as the Great Stupa at Sanchi in India, constructed around the 3rd century BC. The stupa's hemispherical dome symbolizes the universe and serves as a monument commemorating the Buddha's teachings. In creating these structures, builders used symbolism as a fundamental design principle, making each element, like relics and circumambulatory pathways, rich in meaning. The cultural significance of the stupa reflects a unique understanding of the material world as a reflection of spiritual realities. In a different context, we must ask ourselves what inspired the series of grand palaces and gardens in the Persian Empire during the Achaemenid dynasty. The grandeur of Persepolis captures an extraordinary fusion of cultures with its intricate bas-reliefs, monumental staircases, and immense halls. Constructed between 518 and 500 BC, these structures represent not just the ambition of kings, but also the collaboration of skilled artisans drawn from diverse cultures across a vast empire. This melding of artistic styles serves as a reminder of how cultural exchange enriches development, something we see echoed in our increasingly interconnected world today. Equally important is the lesson we get from the technical materials used by these civilizations. The Romans, for instance, were revolutionary with their use of concrete, a technique that facilitated monumental constructions like the Pantheon with its massive dome and oculus. But it wasn't just the material that mattered, it was how they worked together to innovate, adapting their techniques based on local resources. The use of volcanic ash in their concrete, for instance, rendered it non-permeable and exceptionally durable. What would happen if we re-explored the materials at our disposal today? Wouldn't it be something if we were inspired by their ingenious use of local resources? Yet, amidst their unparalleled achievements, the fate of these ancient civilizations beckons us to reflect. What led to their decline? Often, environmental factors such as droughts, resource depletion, and conflict played critical roles in their respective downfalls. For instance, the collapse of the Maya civilization has been attributed to a combination of protracted drought and deforestation caused by agricultural practices that could not sustain their formidable population. The Nazca civilization also found itself at odds with its arid environment, leading to ecological strain. These stories remind us of a crucial lesson about sustainability, a topic that is increasingly relevant in the context of our modern world facing climate change. As we move forward, we can't help but see the connection between the monumental achievements of ancient civilizations, where their creativity was limited only by their vision, and our current challenges. Even today, as we grapple with urbanization, sustainability, and technological advancement, there lies a reservoir of wisdom waiting to be unearthed from the remains of those who came before. Their legacies can fuel our imaginations, reminding us that ingenuity is not bound to the present but is also a continuum enriched by every generation before us. So, what have we learned? The tapestry of human history woven by these ancient civilizations is complex, rich, and fascinating. Each monument, each structure tells a story of determination, a quest for meaning, and the innate human desire to leave a mark on the world. They were not simply about stone and mortar, they were about life, faith, and the entwined fates of individuals coming together to build the unimaginable. In conclusion, our exploration of ancient engineering marvels reveals much more than the technical prowess of civilizations. It uncovers a shared heritage, an enduring testament to human ingenuity, resilience, and unity. As we stand on the shoulders of these giants, we are inspired to take bold steps into the future, armed with the knowledge that when our creativity is paired with collaboration, we, too, can construct the impossible. Each ancient stone serves as a reminder that what we build today should honor the commitment and vision of those who came before us, ensuring that our own legacies reflect the marvels of a shared cultural ancestry. So, as we continue forward, let's carry their legacy in our hearts and minds, an enduring journey that illuminates the path toward our future.